Welcome back to Java Internals Crashcasts. I'm Sheila, and today we're diving into the Callable interface, a crucial part of Java's concurrency toolkit. We're currently in the Futures and Callables chapter of our Fundamentals of Concurrency season. Victor, are you ready to unpack this powerful interface for our listeners?
Absolutely, Sheila. I'm excited to explore the Callable interface with our audience. It's a key component in Java's concurrent programming model, and understanding it can really level up your multi-threading skills.
Great. Before we dive in, let's start with a quick quiz for our listeners. Here's the question. What's the main difference between the Callable interface and the Runnable interface in Java? Think about it, and we'll reveal the answer at the end of the episode.
That's an excellent question, Sheila. It really gets to the heart of what makes Callable unique. Listeners, as you ponder this, consider what you might want a task to do besides just running some code. What kind of information might you want back from a task after it's done?
Now, let's start with the basics. Victor, could you give us a quick overview of what the Callable interface is?
Certainly. The Callable interface was introduced in Java 5 as part of the java.util.concurrent package. It represents a task that returns a result and may throw an exception. The interface has a single method called call, which returns a value and can throw an exception.
That sounds similar to Runnable, which we've discussed before. How does Callable differ from Runnable?
Great observation, Sheila. While both Callable and Runnable represent tasks that can be executed by a thread, there are two key differences. First, Callable's call method returns a value, whereas Runnable's run method doesn't return anything. Second, Callable can throw checked exceptions, but Runnable cannot.
I see. So it's like Callable is Runnable's more versatile cousin. Can you give us an example of how we might use Callable in practice?
Absolutely. Let's say we're building a web scraper. We could create a Callable that fetches and processes a web page, returning the extracted data. Imagine a task that goes to a website, waits for 2 seconds to simulate processing time, and then returns a message saying it has scraped data from the website.
That's really helpful, Victor. It seems like Callable is often used in conjunction with future and executor service. Could you elaborate on how these pieces fit together?
Certainly. When you submit a Callable to an executor service, it returns a future object. This future represents the result of the asynchronous computation. You can use the future to check if the computation is complete, wait for its completion, and retrieve the result. It's like sending out a task and getting a receipt. You can use this receipt to check on the task's progress or get its result when it's done.
That's fascinating. It's like sending out a task with a return receipt. You know it's being worked on, and you can check back later for the result. Now, you mentioned earlier that Callable can throw exceptions. How does that work in practice?
Great question. One of the advantages of Callable is its ability to propagate exceptions. If the call method encounters a problem, it can throw an exception. This exception is captured and stored in the future. When you ask for the result, it will let you know if there was an error. This allows for more robust error handling in concurrent code. You can handle exceptions that occur in your asynchronous tasks, just like you would in regular sequential code.
That's really powerful. It seems like Callable provides a lot more flexibility than Runnable. Are there any common pitfalls or best practices we should be aware of when using Callable?
Absolutely, Sheila. One common pitfall is forgetting that waiting for a future's result can pause your program until the result is available. If you're not careful, this can lead to your program getting stuck or performing poorly. A best practice is to use a timeout when waiting for results to avoid waiting indefinitely. Another best practice is to prefer Callable over Runnable when you need a return value or exception handling. However, if your task doesn't need to return a value or throw checked exceptions, Runnable might be simpler and more appropriate. Lastly, remember that Callable is often used with thread pools via executor service. Be mindful of how many threads you're using and how many tasks you're submitting to avoid overwhelming your system resources.
Those are great tips, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. The main difference between Callable and Runnable is that Callable can return a result and throw checked exceptions, while Runnable cannot do either. Victor, any final thoughts on Callable?
Absolutely. Callable is a powerful tool in Java's concurrency toolkit. It allows you to write more expressive and robust concurrent code by enabling tasks to return values and propagate exceptions. Understanding Callable, along with related concepts like future and executor service, opens up a world of possibilities for writing efficient, asynchronous Java applications.
Thank you, Victor, for this enlightening discussion on the Callable interface. To our listeners, we hope you found this episode informative and engaging. In our next episode, we'll be diving into Completable Future, a powerful extension of the Future interface. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you enjoyed this episode. Until next time, happy coding.